Hey, welcome to the stream. Glad to have you here again today. So, what I like to do is do a little recap of where the game is, and then start on some new stuff. And so, today I don't have a whole lot that I did since the last stream because I've mostly been working on pitch stuff. So, we can take a look at just where the game is now, and then move on to some new stuff. Now, I was doing a little bit of work before the stream that is not done, so what I'm going to do is quickly undo that work, and then I'll show you the game, and then bring that work back. So to do that, first I need to make sure I save, back up all my changes, so I don't lose any work. So let me go ahead and do that right here. It's called shelving, and what that does is just create sort of a temporary backup of these files on my server out in the interwebs, and then I can bring those versions of the files back quickly. This is called Perforce, if you've never heard of it. It used to be it's what's called a source control tool that allows you to manage your changes to your code and your assets for a software project, and have different versions of them, look at differences between different versions of them, and have multiple people all working at everything at the same time, and make sure to stay synchronized. And of course I'm only one person, but it's still handy to synchronize between my different development PCs and to look at history and see if a bug was introduced and go back in time, so to speak. So what I'm going to do is do what's called a revert, and that gets rid of sort of my local changes of the files and goes back to like a previous version. And then if I go to Unity, we can go check it out, and it should compile, and then I can hit play. And I think I did tweak some stuff a little bit since then, and in fact I changed some constants in the scene. Not too much actually. So there's a planet going from like a primordial lava state with crazy volcanoes, and then it's cooling over time because the heat from the sun isn't enough to sustain that surface temperature. And then that's when you see the rock sort of more like a normal rock color. And what happens there is that there's all this heat in the moisture in the air, and it's so hot that it can't condense, but then eventually it cools enough where it can condense, and you get a lot of rain and this cloud layer. And so now you have a more earthy looking planet, but I still have crazy volcanoes going everywhere, and it's continuing to cool, so ice forms all over the planet. But where the volcanoes are, it's hot enough to melt the ice. And of course I can still draw some terrain on the planet and things of that nature. But they're like ice mountains now, except where that lava's coming out. So that's kind of where the game is right now. And now what I want to do is do a little bit of trying to get the simulation a little more physically accurate. Basically what I want to do is have a bunch of stuff that the properties are the properties of the actual Earth, because I think that's a good basis point. So what I've been doing is looking at like how sunlight comes in and warms the surface of the Earth and the atmosphere, and then the atmosphere and the surface of the Earth kind of emit heat back out to space in the form of radiation, and this will form a little balancing act if everything is just right. And so I have this little I've been doing some research, so I found this diagram from NASA that kind of demonstrates what's going on. About like the kind of tan color here is incoming energy from the sun, and the red is what the Earth is kind of emitting back out to space. So an interesting figure here is that we have, so watts are sort of power or amount of energy coming in every second, and there's a certain amount of sunlight that's hitting each sort of unit of area of the Earth. In this case we're talking about a square meter, because in the science world everything's in metric, because it's just a much nicer system to work with. So we have 340 watts. If you think about a PC, like that might be about how much energy a desktop PC uses. A laptop will probably use a lot less than that every second. And so it's basically enough sunlight to power a laptop per square meter of the world that's coming in. And so that energy is coming in. A certain amount of it is just sort of reflected by clouds and other stuff in the atmosphere, about 23% of that. And then the other 77% comes down. Of that, 23% is just absorbed by stuff in the atmosphere. I think it's mainly carbon dioxide, the so-called greenhouse gas that does most of that absorbing. And so that leaves us with about, let's see, that's 46 or like 54, 55%. And then some comes down and hits the surface of the atmosphere, a little over like 55%, something like that. According to this diagram, most of it is absorbed by the surface of the Earth. Of course, it's going to depend on what the material is at that particular point, but that's kind of a general thing. And then of that incoming 100%, which is 340 watts, about 7% goes right back out. And then this interesting bit in the middle is kind of a lot what I'm already doing. Convection is just basically direct contact between the air and the land, causing heat to transfer from the land to the air. And then interestingly enough, even more important than that is evaporation of water into the atmosphere carrying heat. And then an interesting thing is this surface radiation is 117%. So initially the surface of the Earth is outputting more heat than is coming in from the sun. So you would think if that were the case, the Earth would be cooling off, right? What's going on there? And how can it emit more than it got in the first place? Well, everything has temperature, right? Everything has a certain amount of heat. And when stuff gets really hot, it actually emits a lot of radiation. We talk about light. Light is a form of radiation. X-rays are a form of radiation. Radio waves are a form of radiation. It's all radiation. And so that's why, like, if you heat metal, it gets really hot. First it gets kind of like a reddish color, and then it gets brighter until it glows kind of like a whitish color, right? Like, think about like a blacksmith, working on a sword. But the Earth, even though it's not that hot, it's still, like, everything above absolute zero emits some radiation. So based on just on the temperature of the surface of the Earth, it's emitting some radiation. But then a lot of this is kind of either absorbed or by the air or reflected back, and it unfortunately isn't giving me a good breakdown of like how much is like absorbed by the atmosphere versus how much like hits a cloud and comes back down to the Earth. But when you count for all that stuff, only about 12% of that 117% goes back out through the atmosphere to space. And then that's coming from the surface of the Earth. And of course the air in the atmosphere also has heat, so it does the same thing. It emits radiation based on heat. And it says about 50% there, and an extra 9% specifically from clouds, and then that 12%, which adds up only to 71%. And you're like, well, I thought we had 100%. Well, the thing is, initially we had 29% reflected. So overall, that's kind of how it kind of balances out. So with that in mind, I've been working on some better stuff for how that heat dynamic plays to make it more physically accurate. Because if you look at what I have initially, there's a lot of stuff missing and some things are just kind of wrong. You can see like, oh, I have a quick hack here. Now the biggest thing is here I have this like emission factor, and that is basically like it controls how much is radiated out to space based on the temperature. And what I was doing was just a quick, hey, some number I plug in times the temperature of the thing. But that's not really accurate. There's actually, if you look up something called black body radiation, which is a kind of funny name, it just means like if something doesn't reflect any light at all, and any energy coming out of it in the form of radiation comes specifically from its heat, how much would that be? And so you get this equation, and where is it? It's basically right here, there's this formula that says the energy given out is basically proportional to the temperature to the 4th power, which is a really high power. Hey, Jedi Master Goatwalker. Going pretty well, you know. I've got this new project I'm working on. I want to pitch it to publishers pretty soon. It is really early in development, so ideally I would have waited a little bit longer, but PAX is coming up, so I want to take advantage of that event, that opportunity, to see what kind of response I can get. So I'm going to be working hard to try to make this thing as good as possible. And just trying to improve the physical simulation of my planet. And so basically, because this isn't just a linear energy output, but it's to the 4th power, that has a really good balancing effect. So like, even if you put a lot of heat, say like you have a really hot star heating your planet, it's not going to just get hotter and hotter and hotter to no end. Like, this will actually balance it out, so that even if you say like double the amount of sun coming into your planet, you're not going to double the temperature. It'll be somewhat less than that, because the amount of this black body radiation is increasing so quickly. And so I was working on that before the stream started, so let me bring those changes back in. So here we go. So you can see I've got that 4th power here, and this looks the same, but what I did was that so this is in my compute shader running on the GPU, which is where the bulk of my simulation happens, because the graphics card actually has a lot more power to do computations than the CPU. It's just a little less flexible and harder to work with. To put it in like not go into details, but basically I take that initial thing, and then this is like a thing that you just kind of look up out of your textbook, or in these days, you know, out of Wikipedia. I just pulled this value right here, multiplied it in by kind of a factor that you can tweak in the Unity editor, and then everything's sort of scaled by the amount of time that we're considering to pass. And so I have that here. I also did some stuff here to try to tweak the greenhouse gas absorption from CO2 to be a little more realistic. I added in some reflection of the clouds based on that NASA diagram here, right? That actually it's 29%, or no, sorry, 23%, yeah. So 23% will be reflected back out, and then the air absorbs some of that energy, and then the surface gets some of the rest, but then the surface reflects some. So then the air, based on the current temperature, the air and the surface will emit some heat out, but remember that what the surface emits will actually get absorbed by some of the atmosphere too, so I'm accounting for that. So this is all kind of in unison of energy, but what I need to do then is also account for mass. So do I have air mass here? I do have air mass, sweet. And I need what's called land mass as well. And where am I using that? So here, so I'm already accounting for that, so the amount of temperature change should be proportional to that. And so with that, should be pretty good. Now this I think the air will be pretty good. This landmass thing is sort of like a hacky number that I threw in there, which might cause some problems, so I have to kind of see in the future, figure out something better to do there, because like, think about all the mass in the Earth's crust, it's a lot, right? But that heating from the sun is kind of first applied just to like the first couple feet, or even the first couple inches of the crust, and my simulation isn't so complex that it's like simulating every temperature all the way down. So I'm gonna have to account for that here, and I might even do something simple. So that's would be a landmass of like 1,000 kilograms, which is like 2,000 pounds, and we're talking about a square meter. So honestly, that might not be too crazy. You know, say like a square meter is like 3 by 3 feet, and then maybe like say the upper foot or something. It might be okay, but it's definitely gonna throw off what I had here before because I had tweaked some numbers based on the previous math. And surface emission heat. So let's see what happens. You know, it might get really cold, it might get really hot. Let me just rename that so that everything is happy. Air emission. Air emission. So this is wrong. This, because that's just directly modifying the temperature with the heat. But like I said, you have to account for the mass. So divided by the land mass plus the water on the land, because we're also considering it to heat that water. And then the area. So this is gonna definitely make things different, but hopefully better in the long run. And once they like plug in all the numbers that are like real Earth numbers, right? Because temperature, you know, we think about temperature as like, oh, it's hot. It's sort of a feeling, but what it really is like everything like air is made of all these little particles, and it's the average energy of all those things. And so even this isn't quite correct because it's per particle, not per unit of mass, and like different types of chemicals have, you know, they might be heavier or lighter than others per like individual particle, and that's kind of part of what this like kind of specific heat thing is, but it's like a quick hack. But in the future I'll do crazier stuff to make that more physically right, but for the time being, let's just see how this goes. So my planet didn't cool that much. So what you have, why it looks green, which is pretty cool, is you have this kind of dark rock under some water that didn't earlier. The water was fully evaporating, but if I look here, I should see that if I look at how much surface water I have, yeah, I have like fairly deep oceans, you know, a few hundred meters, and that's gonna absorb all the red light out, and I guess there wasn't much blue light reflecting by the surface in the first place. I also have to include like the water into these heat calculations better, so it leaves only kind of green light coming through. So let's see what my surface temperature is. Oh, it went crazy. So that might be part of the problem. So this is like the total heat. So I'm not sure exactly where that problem is coming in. So we're gonna have to try to like take some stuff out little by little. So I'm going to see if I can see maybe if there's any kind of trend that happens before it goes crazy, or if it's immediately crazy. That was pretty immediate. So I'm gonna guess if I just take this out, maybe that's, it's either that, it's like a 50-50 chance that that's the problem. I guess if there's no air mass, I'm dividing by 0, and that's the real problem. Yeah, that is the problem. Okay. So I just need to account for that. So if air mass is, what I should really do is say, do that only if air mass is greater than 0. Which I don't know why it would be totally 0. So that's a little bit of a mystery. And so maybe that's not the actual problem. Okay. So maybe it's this line here that's the problem. And that's okay. So maybe the problem is coming in here and it's somewhere further up. So if we say air emission is 0, so kind of isolate that. So it seems like this air emission thing is going crazy. Maybe it's something with this, the air temperature being... What is the air temp? So the air temperature I think is going to start off at 0. Which should be okay, like there's no wrong thing here. But let me just, as a quick test, try something a little different. And that just goes crazy. Maybe because the air temperature is so hot that there's so much coming out that it just can't handle it. And so that's interesting. So I bet if I just sort of put a cap on this here, like 10,000. Still doesn't like that. Raising stuff to the 4th power is actually like a really extreme thing. Like if you do 1,000 to the 4th power, that's 1,000,000,000,000. So I think I'm just going past the range of numbers the computer can represent here. So I'm going to try to kind of find, what does it go crazy? And it looks like it's fairly low. Which is weird. I don't know why it's not a problem for the surface. Because the surface also is over 1,000. Its power level is over 9,000. Is maybe multiplying by the air mass is enough to like do it. So if I take that out for a moment, do I still get craziness? answer is no. So that's blowing it up just enough, apparently. Oops, that was wrong. Yeah, so something about multiplying by the air mass, which isn't that large of a number, so that's really weird. Well, I guess it is kind of high, but it starts off. Let's see where it starts off. A few hundred, I guess. I guess that's just enough to blow it out of the water. Now what I could also do is use a higher precision type of number. So if I take everything here, and so I have this thing called float, and there's a thing that has double the amount of precision. It's called, or it can store double the amount of data, you could say. It's called the double. And that might actually get me there. And it does not. So I don't know why that's such a problem, specifically with the air. And I could, for the time being, just ignore that problem. And I know like the default amount of air is around 10. So if we ignore the extreme conditions at the beginning of this planet's formation, then actually we're okay. So I could do like min air mass, like see, clamp it at like 20. So that's all fine and dandy. Now an interesting thing, so if, when I get going, I can actually just pause the simulation and look at like what's the initial state of stuff. And if I look at that, the surface starts at 5,000 degrees and the air starts off at 0. So I don't know why the air one is blowing up so much more than the surface one. It's a little bit of a mystery. But then if I simulate for just a moment, it's still a lot cooler in the land, so it could be some weird optimization that the shader compiler is doing that makes it not able to handle larger numbers. I really don't know. Where am I looking for? So right now I'm looking at the air temperature, I'm looking at the surface temperature. It's a lot higher, 4,000 versus the air is only at 1,500 degrees. So you can see, like, there's a lot that I'm trying to put into this simulation to get it to have lots of interesting outcomes that can vary a lot depending on how you set up your planet in the first place, or like what you do to the planet as it's going through space. It could also be that this some weird low value coming in maybe? I'm not really certain. And I gotta start my simulation. And that didn't help. The only thing that seems to help is just saying don't multiply it up too high. Huh. So it seems like sometimes going really low can be a problem too for some reason. Surely don't understand. Or not. Okay. So we're gonna ignore that craziness for a second and just let the planet evolve. And what I want to see is like what kind of steady state does it come to? Does it come to a sort of a climate that can support life or not? So because I've got, as you can see in how I set up the planet simulation, so the sun heating factor is like in multiples of how much of the sun's actual energy hits the Earth. The space emission factor, I should probably make that like 0.8, because I've read that's kind of what that's interesting that made such a big difference with what the actual Earth is like. So I want to take a look at, so something went crazy when I increased the space emission factor. So that's another weird thing as I try to make this thing more physically accurate. So there's my surface temperature, and I'm also curious about the air temperature. I go back here and I try to raise this up. Should theoretically get cooler. Until when it hits a certain spot it just goes nuts. So I'm kind of curious to look at why that might be. So let me start off the simulation like that. I'm going to step into the code a little bit. First thing I'm going to check on the CPU and make sure that the data I'm sending from the CPU to the GPU looks reasonable. So I think maybe just increasing that made all the numbers blow out of the range. So actually wait, yeah, I don't need to multiply by the mass there, do I? Because it's just this thing formula alone gives you energy, so that helps out. And I wonder if that affects anything. That's actually seeming to help a lot. Hey, it helps if you do your calculations physically correct. What do you know? What do you know? So my air temperature is kind of, seems like it's fluctuating a little bit, but mostly going down, which is what I expect because it's pretty hot. And what I want to do is actually do a visualization of how much energy the surface of the Earth is giving off, which is kind of just the temperature's going down. You should see giving off a lot of energy. So we're kind of stuck here at this 850 degrees range, which is really freaking hot. Really hot. Some people like it hot, but that's a little too hot. So it's funny how I've got almost like a diamond-shaped planet here as all these volcanoes are going nuts. I really turned up the volcanism really high here. So what's interesting is I'm watching. Well, the surface temperature just because the volcano came in. So I'm gonna turn off my volcanoes because it's like messing with my ability to actually like watch the patterns in the surface temperature. So as the sun comes, it should get warmer, and it is, but not as fast as you'd expect. And then it's kind of slowly just getting warmer, which I don't quite understand. And the planet looks pretty wild right now. If I turn off the atmosphere and just look at the planet itself, it's kind of this crazy mixture of like volcanic rock and other stuff. And there's a little ocean just right there. Even though the planet's really hot, it seems like right here it's a little bit cooler for some reason, and so the ocean kind of stays there. And that must mean there's a ton of atmospheric pressure as well to keep that water from evaporating. But look at the air pressure. Yeah, it's like 40 times what it is on Earth. So my little rock in space. Where'd my ocean go? There it is. I have to think about, well, what could be causing it to be so hot? I didn't exactly expect it to be like Earth temperatures, but because I don't feel like I've done everything yet, but I'm trying to think of, okay, what pieces of the puzzle am I missing? And I'm kind of curious what the air temperature is doing, if that's fluctuating a lot or not. And that's also staying really constant, which is kind of surprising, because as the sun goes around, you expect some changes. So as like a quick test, if I just make the sun a lot hotter, what's going to happen? I'm not really seeing much of a change. And you know, you kind of want to blame this fourth power emission thing here for that. But it is the physical thing, so there should be, it shouldn't make everything totally constant. And so if I look at it now, it's definitely getting some changes, and now it's just getting hotter as less and less heat is emitted back out to space. Still fairly constant, or slow changing, I should say. And if I go and let's make it a less space emitting thing, then you should see it heating up even more, and it is. And that heating seems to increase during the daytime, which makes sense. Now let me think about what I'm doing here. Let's go back to our little NASA diagram. So I shouldn't need to put the number so low, because anything less than 1 should be reasonable. And I think I've read that there's this thing called the emissivity and they said Earth is about 0.8 in some of the sources that I looked at. So temperature, what I'm gonna do is do a little debug visualization. So I'm gonna go to my pixel shader here, and I'm gonna output two things. One is the temperature, and the other is like how much heat is coming out. So first I'm gonna go and I'm gonna say let's do some debug output, and I'll say what that debug output is, which is not going to be what it was before, and I'm going to say that I want to have light coming out, of the camera towards my eyeballs. That equals the temperature, which is in dot, and I'm going to go first with the surface temperature. That should be all white because it's greater than 1, right, or like 800 degrees. So if I divide by 1,000, I should get something that's not white. Maybe 2,000. And I can even do like minus 800 divided by 200. Well, I'm looking at the air temperature there, that's why. I need to look at what's the surface temperature. It must be quite a bit different. Yeah, the surface is a lot hotter than the air, which makes a little bit of sense because I reduced the space emission factor so that the surface itself is emitting less heat for the air to absorb from it. So now I can see kind of where the hot spots are, and you can see as this, I'm assuming that's as the sun's coming on. Well, and I'm gonna say dot just the red. And I'm gonna make it blue where it's kind of lower than that. So blue should represent cool. Temperatures are staying fairly constant, which is quite a surprise because in my earlier simulations there was a lot more fluctuation, but I guess that's owing to that whole fourth power thing. So, let me think about how I want to do this. So, I was dividing by the mass, right? But like I said, the mass isn't exactly correct because it depends on the number of particles in that mass. So I'm just going to put in some little fake factors here for the time being. And that should cool everything off quite a bit. I can see my surface temperature dropping, kind of slowly, but it's dropping. But then it's going back up, I guess, when the sun comes out. So sometimes when you have a little problem, it's helpful to sort of set it aside for a second. So I wanted to go and look a little bit more at the wind stuff because I felt like that was, it might just be a little more interesting to look at right now. So I'm going to go ahead and back up my work here. gonna turn off my little debug output because I don't need that crap anymore. Not anymore. Now let's see, like, oh, the value's kind of what it would do. So I look at, I think this was something like that. So now it should kind of act like it did before I started messing with everything. And while I check that, I'm just gonna get a quick little bit of water. And I can see all the smoke in the atmosphere from all that volcanic activity. Okay. I love that light blue color coming in with that kind of noise texture. Now, what we're going to do is I'm going to start working on the wind stuff. Let's see where I left it off. So I was doing this thing where I was taking the wind and I was storing it in these sort of local polar coordinates, and then I was doing math in like full 3D, and then I was stuffing it. Where is it? If I scroll down, man, I have a lot of code here. Back in. But what I think I'm going to do is try to do all my calculations just in that polar coordinate system and try to avoid that whole problem. So I come up here. Call it wind polar. I'm not even going to use this my wind velocity actually. Totally ignore this other stuff that I had. But what I need to do is take this vector and make it in that polar coordinate system. So I'm going to look for how I built that. So to do that, I need to get the local coordinate system. And I have to physically compute a transformation. So I'm going to rename that so I don't accidentally use it. Go to neighbor polar. So by doing this thing called the dot product, I can kind of compute how similar two vectors are, and that's what I'm going to use to do this. So like the x is how far along the tangent that other vector from this point to its neighbor is, because basically if you look at the sphere, right, it's got all these triangles on it. Let me try to get close here and turn off some of this other stuff. And so every point, almost every point has 6 neighbors that it connects to, and so what I'm doing is I'm doing a simulation at every single point, and then I'm doing like the pressure differences between each point to generate wind between these. So like if I'm examining this point here, I have to look at the 6 neighbors and say, okay, there's a vector going between us, like an arrow, basically like a direction, and I need to compute like what's our pressure difference, and then sort of based on those pressure differences and the directions, get an overall direction for that point. That's what I'm doing. So I do that by doing these little math operations here to get that coordinate space change. So now I have that. And so I have to replace all uses of that old variable. You know, when I'm working on this game, it's weird how, like, when you're working on the game, you have these, like, emotional ups and downs where sometimes you feel like what you're doing is really cool and that people are going to like it, and sometimes you think, oh, this is never going to work. And feel a little bit of that as just over the course of today, for example. And when I said this is never going to work, sometimes it's like, oh, you think, like, technically, like, it's not going to play the way that I wanted it to play, or sometimes you think just people aren't going to be that interested, or sometimes you do, and it's really hard to gauge. One thing that's tricky about this, like doing like a planet simulator, is that people can sort of put their own ideas into that concept, and you don't, so they might get excited about that concept in general, but you don't know if what you're building is really going to fulfill like their fantasy of it, because everybody got their own version of that fantasy, if they have it, that fantasy at all. So as I was talking about that, I kind of lost track of what I was doing here, right? So let me see how I'm using this. That should give me something. That's the wind. That's the air pressure. So right now I'm using all that fake wind, but I want to get rid of that fake wind from the texture and say that it's this guy right here, which is actually like my simulation value, which should start off at 0. So what I'm going to start off doing is just disable all that wind stuff and all that air pressure stuff, and just kind of make sure everything's what I expect it to be. So I expect there to be basically no wind. There should be actually some changes in air pressure from other stuff, but the air pressure shouldn't be affecting the wind yet, or moving mass around, like kind of diffusing really too much. It looks like I messed something up here, so I'm just going to take a quick look at what I did. Oh, it's because I had a little typo there. Alright, so I don't need to put this keyword. That's only in C#, not in the shader language. So, ha. So if I look at the wind, it's 0 everywhere, which is good. I'm curious what the air pressure looks like. It's really high, kind of everywhere. So I want to wait for the planet to kind of stabilize a bit before I start looking at this stuff. Okay, so now we've got liquid water. The air pressure is rapidly dropping. And once it gets down to about 10, then I'll be good. And that's close enough. So now first I'm going to enable just the air pressure stuff and see how that affects wind. Or actually first I'm going to look at the air pressure with a visualization. So it's going to be red where it's high air pressure and blue where it's low air pressure. And you can see there's a little bit of change over time, but nothing crazy. And then when I enable this sort of diffusion based on air pressure, you should see two things, hopefully. One is that it kind of starts to even out and you see more change, and the other is that we get some wind velocity. So I'm going to try to look at both kind of at the same time here. So in the corner you can see my air velocity 0, and you can see that also represented by the fact that this arrow is kind of pointing straight up out of the planet instead of along the surface of it. And then we look at the colors to kind of indicate air pressure. So now I made my change, or I thought I did. And I'm gonna quickly fix a little thing that I forgot to adjust here. That should do it. I'm getting some crazy big winds, and it seems and as I do this, I'm kind of curious about the air pressure. It's like most of the planet is high pressure, and it looks like just a few areas are low pressure, and it makes me wonder like if I made a mistake somewhere. So, and also I'm curious, what is my temperature? Kind of below freezing temperature, so 273 is like the freezing point of water, and you can see I'm pretty below that. So I have this way of displaying like the average values across the globe, and like if that changes, that lets me know that something crazy is happening. So I'm just going to turn that on so I can see what's going on. So you can see this average air gases is 10.3, and it's being pretty steady. See my pressure is super high as the planet is really freaking hot. Really hot. And as that planet cools, you'll eventually see some white and blue zones come in. This is actually how I do a lot of my debugging, is just kind of outputting colors all over the surface of the planet to represent numbers and help me understand kind of the global picture a little better. Because I've got just 40,000 vertices in this case that are all simulating, so I can't think about. It's hard to find another way to kind of look at that much data all at the same time. So you can see my air gases. So air pressure is a combination of what I call the air gases, which are like oxygen and carbon dioxide and nitrogen, and any water in the air, and if there's any ash. But should be very little ash. And so that's good. But it is strange that I'm like at high pressure at over almost the whole globe. So I wonder what's going on with the water. Maybe there's a lot of water in the air in certain spots. And it's probably due to the volcanoes. So I have volcanoes running. So let me turn off my volcanoes and see if the air pressure can drop a little bit. And it can. Look at that. Those volcanoes are just creating lots of hot spots. So now I feel a little less crazy. And now it should be kind of 50-50 on my little Pepsi wall. It's like a Pepsi tennis ball. Pepsi World, Pepsi ball, whatever. Okay, so now what I want to do is go back to my simulation shader, but I saw that the wind was going like to really high crazy values before. And I can see that it's slowly leveling out, which is exactly what I would expect to happen. So everything's kind of going toward white, which means like average temperature. And what do I want to look at? I want to look at the wind speed. See, I have like really crazy wind speeds. So what I'm going to do is every frame I'm going to reset it to 0 and see just like, okay, based on this one frame, what would the delta be? And that should be based on the air pressure. And when I say delta, I mean change. That's sort of a nerd way of saying change. So I'm going to say 0. Bam. So now all my wind is 0. And you can see it's not exactly 0, so I have two numbers which are the x and y, and then the other numbers like the total magnitude of the wind, and it's not exactly 0 because of the little changes I make in every frame. But I want some pressure differences, so I want to put my volcanoes back on and see if that gives me some pressure differences, and it does. And you can see they're like pushing that hot air all over the earth and throwing a lot of air water up into the air basically. So then I can set that back to like a reasonable number, like 1, and maybe occasional volcanoes appear. So my air pressure is a little kind of high, but it's falling to be something more reasonable. So I'm going to pause it here. And actually, what I'm going to do is pause the simulation so I can just kind of inspect like what wind values are being generated by these pressure gradients. So I'm going to come here, I'm going to turn off my simulation, which stops really change from happening. But I can unpause the game so I can still like do my controls and things. So if I look at the wind, so that looks good. It should be going from the red areas to the blue areas, which is what it's doing. It seems like it's just sort of in a runaway. You can see in general things are, I don't know like what kind of changes are happening within this red area really, but as we get close to these blue and white zones, the arrows should point toward them, which seems to be roughly what's happening. Not like that is what's happening, except you get some places where it seems like, yeah, it's kind of it could go either way because like this high pressure is kind of trapped between these two low pressure zones, and so there's a transition point, and so that's why my arrow is kind of flickering there. And I'm curious if I can get a little more detail. We're getting kind of like ISO lines by, or not even ISO lines. Actually, ISO lines would be pretty good, but more detail by kind of I think everything is getting sort of really blown out really quickly. So if I scale everything down, it should allow me to see a little more detail. So I'm going to go to my debug shader here, and I'm going to just kind of make that a tenth as strong as it was. And you can see there, that's pretty good. But I do like that concept of ISO lines. Although even just having that little gradient there, I can see more clearly what's going on. So I have this cell shade thing, so I might be able to use that. The cell shade is like cartoon shading, you know, where like they're not that smooth of a gradient. It's like this color and then that color and that color, and like it gives that cartoony look. So I'm gonna say 0.1, 10. So that should give me like 10 gradations. Except I had a little syntax error there. Perfect, look at that. Oh, it's kind of beautiful. I have actually been thinking like it might be cool to like ship some of these crazy visualizations with the game. Just, you know, more interesting things for people to look at. I don't know if it's interesting to you guys to see stuff like this, especially as it changes, but I think it's pretty cool. And so it's kind of like, you know, if you think about like a relief map where like the different lines represent the changing elevation, except it's just like that, except instead of elevation, it's pressure. So like all along this line here, it's one particular pressure value, and then this is another one that's a little higher pressure and a little higher pressure, and then going the other way, this is one that's a little lower pressure. And so you can see the further apart the lines are, the slower the change is. So like in these like middle pressure areas, you have slower change, and as you get closer to the centers of these volcanoes, you get the pressure changes being quicker and quicker. And I'm finding this pretty fun just to look at and play with and tinker with it. So you can see the area kind of, everything should be pointing toward that more whiter area, like the brighter white area there, and things should be kind of here contouring along these curves. So overall, so you can see as I get closer, I should probably move that arrow to be a little closer to my cursor to like see what it's actually connected to. But like if you look at where my actual Windows cursor arrow is, it's like right next to that little border there, and it's pointing kind of inward toward that border. So that makes total sense. So the wind vectors that I'm generating, and I think this is actually the way I did it using everything in polar coordinates, is actually probably a little bit simpler to do in the end. Well, I don't know. Conceptually simpler. In terms of computer time, it's maybe just a little bit slower, but it's close. And I'm not really worried about that right now. So okay, so I have good gradients here. So I think the air pressures created by my volcanoes, just because they're so hot, are just getting out of control. But I'm curious to just, so right now I'm basically resetting every frame the speed to 0. So any wind speed that you see is based just on the calculation for that one particular frame, not accumulated over time. But if we go ahead and start the simulation, it's all looking pretty good, and it looks cool to see the pressure sort of diffuse around until like a new volcano appears. This one seems to I don't know if it's growing or shrinking really. This one is obviously a new one here that just spawned in. And what should happen is, you tell there aren't a whole lot of blue areas, because those volcanoes are creating so much air pressure that the whole global average is being thrown off. So I have this like fixed value of, and it's also throwing a lot of water into the air, which is creating that air pressure. So what I'd like to do is sort of like use a dynamic average for my debugging purposes, so I can make everything relative to what the current global average is, which will make it a lot easier to see this stuff. So it's not too hard to get that data. I believe I already have that data coming back on the CPU, and then I need to just pipe it back into my shader. So if I go to, where was that file where I was? So I'm already displaying this stuff, average and total water and air gases, and I add all that stuff plus the ash, and then I have my total air pressure. Well, this is water on the land too, but I can take this and calculate like what's my average air pressure across the whole planet, and then pump that into the shader. So I'm just going to do that here, and the time being it's only for my purposes, but like I said, maybe if like I put some of these cool visualizations into the actual game, it could be useful. Average air pressure equals all this stuff. So I have the, I have to look at how that stuff's stored. Just equals, so I just have to add these four numbers together basically. Or sorry, 5 numbers, because I have air. I basically have up to 5 different things in the atmosphere. I have oxygen, carbon dioxide, nitrogen, water, and like ash or particulate matter, like smoke, basically smoke or ash. Hey, what's up? This is Odzerk. Thanks for coming to the stream. I'm just working on some stuff, trying to get my winds going better. Earlier, I was working a little bit on making like the heating from the sun a little better. You know, I had this diagram from NASA about like, oh, light comes in and some of it's reflected by the clouds, and some hits the ground, and some's absorbed, and some goes out, and then there's evaporation and all this stuff, and then the Earth kind of radiates heat back out to space, and it all should kind of balance out at the right temperature. And I was working on that a bit. I hit a little bit of roadblocks, and now I'm going back to, or like I should say, like a little bit of an issue that I didn't feel like debugging right now, so I'm going back to the air pressure stuff. Yeah, I saw Goat was in here earlier. I'm assuming you sent him. Thanks for that. And what is this music? This is not what I like. I have it on this synthwave station, which sometimes has pretty cool stuff, but that was like a little too 80s for my tastes. So I'm gonna just say I'm gonna set a value in the shader. That is my average global air pressure. So I have to actually make that value in the shader itself. And I just like to organize this a little differently. Except I just realized I'm putting that in the wrong shader. I want it on this one because this is where I actually do those visualizations. So I want the planet, that terrain material. That's it for. But I want to, since this isn't specifically for the simulation, I want to move it somewhere else. Make a new function. It's always nice to kind of divide stuff into little bite-sized chunks of work, so you don't just have this massive blob of text and you don't know what the hell is going on. So I'm going to call it update visualizations. You don't mind any music? You don't like country and R&B. Is that why you got out of Vocala? So now I'm here back in my shader that draws the surface of the planet, and I use it to do these little visualizations. Debug output. And so instead of this 10.3, I'm just going to subtract the average air pressure, and then I'm also going to divide it by that average air pressure to make it a percentage. But I want to show only like differences up to maybe like 30%. So I'm going to divide by 30%. That should give me, how much longer am I on today? Till about 5. So I should have, shouldn't be all red like this. Just to make sure this is. If I put it like a really crazy high number in here, it still seems like it's not even having any effect. So I'm just gonna make it, I put green just to make sure I'm not going crazy. Okay. Now I want to see what kind of value I'm getting on the CPU. It's 57 is my average air pressure. Okay. That seems okay. Look at individual air pressure values. They're kind of all over the board, but some of them are like 20 something, so I don't know why. I'm trying to figure out why that's red. Let's just keep it simple, stupid. It's still making me scratch my head a little bit. Oh, thanks, man. It's so... The air pressure is less than like a huge number. We should output, let's say, blue. Okay, that's good. Why is nothing ever less than the average? That's what I want to know. If I'm looking at, or nothing, everything's less than 50 I'm looking at. No, everything's less than 50, so it should all be kind of blue. Oh, because I'm dividing by itself. That was just a stupid copy-paste error. Ugh, okay. So let me come back here. Divided by the average air pressure. Okay, there we go. So now I'm going to go and look at my wind again. So you can see the wind started pointing out from the red zones, which is good. That's exactly what I want. And now I'm going to go to my simulation and I'm going to try to actually make those values like keep going over time. So our wind is blowing like up to 8 miles per hour, which is like a lot of change in one frame. So I kind of want to tone that down. It's called wind adjustment, I think it was called. Let's just look for wind polar. Where's my... Okay, so here's all my air pressure calculations, and I'm updating the wind speed based on the direction between the different points I'm simulating, and like each cell is like moving air mass into neighboring cells, and however much mass I'm transferring over, that is basically how much momentum I'm transferring over. Theoretically, I should consider the air speed of that mass as well, and use that instead of just the direction between. But for now, this will be okay. Except, well, I'll consider that stuff over here. But I'd have this sort of like, well, how fast does pressure push stuff out? And I need to like think about like more like what would be the real physical things behind this, like if you consider like the size of the stuff compared to Earth and all that. But for now, I'm just using like little slider bars essentially to try to adjust that. Hey Tony, how's it going? I'm just here looking at my planet, and I'm trying to work on wind and air pressure. So it's looking kind of Pepsi-like because I'm doing this visualization of air pressure where the red zones are higher than average air pressure and the blue zones are lower than average, and the white is kind of right in the middle. And you can also see I have this little arrow attached to my cursor that tells me what I calculated for that frame, what the change in wind should be based on that. So it should be pushing away from those high pressure areas, which is exactly what we're seeing. So that seems pretty good. I'm happy with that. But right now I'm like not accumulating that over frames, and I'm just about to do that. And what's happening actually is not only is there like wind vectors being generated, but it's actually moving air mass between the cells, and that's why you see one of the reasons why you see pressure changing. And right now I have volcanoes spawning here and there, and that's why you see these high pressure regions pop up. Like if I turn off my my other shader, if I turn off my little debug visualization, you'll see like a volcano like at the center of this red spot, for example. And another one down here, and another one here. Okay, so I want to look at wind and actually see it like accumulate over time. Oh, and one other thing was, so this planet, those volcanoes are popping out. If I turn off the volcanoes, you should see things kind of slowly go back to like a medium white air pressure where things kind of level out all over the planet. And so you can see that starting to happen. Those volcanoes will disappear, and then once they disappear, we get a lot more evenness and a lot more gentle pressure gradients. At some point, I'm gonna have to take another look at the volcanoes and make sure they don't create such crazy, like just like making the atmosphere like 20 times heavier kind of stuff. Meteorologist Dan. I could be a weatherman after all the research I've done for this game. With Kung Fu green screen grip. So I paused the game, but I want to let like Unity still run, but pause like changes in the simulation. So I'm going to disable this checkbox and unpause, and you can see all our little arrows here, still kind of pointing in the directions we expect them, away from red toward blue. And you can see these ISO lines that are like areas of equal pressure, just like meteorology bullshit. And so now I look at the numbers, you can see that the velocity like changes that it's generating per frame aren't so crazy. They're like, like 0.01 miles per hour kind of stuff. So with that, I'm going to enable like the accumulation of those changes and see if I get some reasonable wins. So doing this right here, I was just setting it back to 0 every frame, but now I'm like saying preserve the old value and then add the updates. And so we won't see as direct of a 1-to-1 correlation between these lines and the direction of the arrow, because those lines won't change over time and the arrow will still carry some of the old stuff, the old wind direction. But see how it goes. So let me turn on the simulation, and you can see it's like kind of in the direction, but some of the old stuff is still having an effect. And we can see that our winds are up to like maybe 10 miles per hour, but hopefully they don't like go super crazy. And look, yeah, because before with all those volcanoes, I was getting like hundreds of miles per hour stuff going on, maybe more. But now that I've let everything kind of settle, you can see I'm getting more reasonable wind speeds. A few hot spots, 11 miles per hour there, but not too crazy. And so I'm kind of curious to see what that does to the clouds. So I'm going to turn off my little pressure visualization and look at like the normal view of the planet. And looks like it's covered in ice. It is covered in ice. I look at my surface temperature. Where would I look at that? With this little tool here. Yeah, it's below freezing. So there are a couple ways I can play with that. One is by making the sun output more heat, and the other is by adding more core heat coming out of the center of the planet. And the third is by making it emit less heat out to the atmosphere. But let's make the sun a little bit hotter, because that gives you some uneven heating, which I kind of like. And my temperature is not changing that much. So what happens if I make it really crazy, like 50? Oh, look, there's some life spawning there. Some grass is growing, but then I guess got too cold again and it died off, but then it's getting warmer again. And like the simulation I'm doing for like where vegetation comes in is like super basic right now. It needs to be a lot more interesting, but it's a good start. So I need some clouds. So I'm gonna make the surface emit a little less heat back out. And now I'm like burning everything with super hot temperatures. Okay, now we're getting to a place where we have some clouds. Hopefully it stays there. But it's a little too cloudy. It's like tons of clouds. I need just a little bit of cloud so I can kind of watch where they go. I want to draw some land while I'm waiting for that, and that should help break up some of the clouds a little bit. My clouds are kind of cutting into the planet there, so I'm going to raise them up a little bit. So if I go, I want to look at my wind again and see if it should be pushing these clouds into this gap here or not. It looks like wind is blowing like 25 miles per hour right here for some reason. But I haven't actually really enabled the moving around of stuff with wind yet. So let's be crazy and pull the switch. There's all this stuff right here. Something's gonna go wrong, I'm pretty sure. And I just realized that the thing I'm using to display the arrow is... No, that's right, but it's... Well, my wind is like really crazy high with something I did, so that's gonna cause problems. And thus I get my little... Yeah, it is a cloudy day. Cloudy day indeed. So something in this code here is making the wind go crazy. So I want to try this again. But with these two lines disabled because they're a little bit suspicious to me. They're kind of culprits, or potential culprits. So what's interesting is the airspeed here isn't getting that significant, which I would expect all these volcanoes to generate a lot of wind. And now I'm getting really fast winds. I guess the pressure differences just weren't that great when the whole planet was super hot. And I can see that I've got wind kind of pushing away from my volcanoes, which is pretty cool. So if I had some clouds, maybe they would push those clouds around. And the air is 400 miles per hour here, so that's a little crazy. And I need to raise up my clouds because I was playing around with stuff and now they're like below the land. Oops, not that one. My clouds, yo. So I want to... Surprised that I'm not getting like rings of moisture around this volcano, which I have been seeing in the past. Maybe the wind is just blowing it all away. So let me try again to disable all the moving of stuff around by the wind. Let's see what happens. I'm kind of curious about where all my water is. Are you planning on having air change per elevation, like rise up over mountains? I definitely am. That's actually one of the original things I thought about was, you know how mountain ranges can affect the weather. creating rain and creating deserts and all that stuff. So what I want to do is look how much water is in the air, and there's like not very much water, except there's a lot of water. Over the volcano there's a ton. Oh, my clouds are turned off when I do that. Oh, there we go, now we can see some freaking clouds. That makes sense. And there's a lot kind of all over the planet. I want to create just some land masses here. Frozen landmass. So my planet is really cold, and what I can do to warm it up as a test is make it just emit less heat back out to space. Ooh, it got really hot real fast when I put it down to 0. Oh, because I adjusted the wrong value. That's the wrong thing. That was just getting a ton of like core heat from the magma center of the Earth. So, look at. Okay, so oh, that looks pretty cool actually. With all those volcanoes now and the water kind of rising up. Man. Okay, so we have these clouds, right? And we can kind of see the patterns of them. So now what I want to do is I want to look at my wind velocity, and then also re-enable the, and I should put a little slider in here to adjust like the simulation speed so I can more easily look at values sometimes. But what I'm going to do for the moment is pause the simulation, but I can still look at my wind. And you should see kind of mass moving around from both just general diffusion, as well as once I enable it, the wind, and even the just air pressure direct calculations, like, hey, you're next to me and you're lower pressure, so I'm just gonna move some stuff your way. So let me just take a look at something here. So these cloud regions I think are dark just because they're getting a lot of volcanic matter in them. So I'm going to turn off, I'm going to really reduce the amount of volcanoes that I have going on. And then I'm going to start my simulation again. And things are kind of getting cold pretty quickly without all those volcanoes. In fact, let's look at the temperature. Yes, below freezing. But what I can do is make the planet emit a little less heat back out to space. Sorry. Okay, so now I have some volcanoes, not like a crazy amount, but some. And you can see that air pressure is kind of making these cloud rings expand away from the volcanoes. But then when I add in wind, that should do it even more. And the stuff's really diffusing around the planet, so it's still like more than I want. So I'm going to even more reduce the amount of volcanoes. Because the volcanoes are good for generating like some initial clouds, but I want to have just a little bit so I can see it blow all around. And so wherever the clouds are is basically where it's raining. So hopefully they can, some of them can kind of rain themselves out. but if it's also evaporating at the same time, that can give you like a permanent cloudy state. So if I look at the air relative humidity, it's only like 0.23, but as it raises up through the atmosphere, it can still generate clouds, and then at the surface, it's also pretty low. So I'm trying to think, what can I do to what's the surface temperature? It's pretty hot. It's actually pretty hot, 375. That's like almost boiling point for our world. So I want to put a little more heat back out to space. These are Earth-sized globes, and is the time sped up? Yeah, the time is sped way up. You can go through like 1 billion years in 10 seconds, you know? And the intention is to like do all the math so that this is like an Earth-sized planet, but I haven't really gotten there yet. Okay, so now these are like livable temperatures. This is like hot, but it's like being in the tropics, this temperature. Okay, so if I go and put a little bit of heat, I should apply a little heat. I should be able to create some clouds. Boom, and you can see them sort of diffusing around. But I'm also curious to look at the wind around there. You can see the wind is doing a little bit of weird stuff, but mostly outward. So now I'm going to re-enable some of this wind stuff and see what happens when I burn some water. So my wind vectors are going like all kinds of crazy directions. So I want to look back at my visualization for the air pressure. So I'm getting some wind going in toward the volcano, which is a little weird. Little weird. I'm going to reset all my wind to 0 for a second. So yeah, that effect in one frame is all pushing outward. And then what's interesting is all that pressure pushes outward, and somehow it becomes low pressure once that volcano disappears. Okay, so that's kind of what I expect. What you could do is make landmass look more like our continent and see if the wind looks anything like it does on Earth in real life. Yeah, at some point I want to see if I can take an actual, populate the globe to look like Earth, and then see what kind of results can I get. But the physical simulation, I know, just isn't there yet. So I have some more work to do. But we're thinking kind of alike. So right now there are these crazy high wind speeds on the planet. And that's kind of messing some stuff up a little bit. Like those volcanoes are creating such crazy pressure differences. And there's something with preserving the speed between frames that's also screwing stuff up. Like it just gets out of control when you keep adding frame after frame. I don't have anything to like, I don't really have any like friction with the land or the sea, which is something that I need to add. Because otherwise the wind just kind of gets out of control. But what is cool is that if I turn off my visualization here, and I turn off all like wind stuff, like where do I use this? I use it here, and that stuff. And I turn off the air pressure stuff. Then as I create a little ring, see how I create the ring around the volcano, and it's in a pretty small area around it, and it doesn't really appear to be going too much of anywhere. There's a little bit of change happening just because as temperatures fluctuate, like where condensation happens can fluctuate, but it's staying kind of localized. And if I allow pressure to affect stuff, then it pushes way out. So that's pretty good. But I want to try something where I don't actually directly transfer any air or anything based on the pressure transfer, and I rely only on the wind that is generated by the pressure. And right now the wind factor is like really low, I think. So I'm gonna, or like the amount of mass transferred by the wind, I should say. So if I increase that, hopefully you can see more stuff happening. That's interesting looking shape. It's interesting that it's like not a perfect circle for some reason. That one's more circular. Maybe it's because there was some latent wind speed going on there. I go back to saying resetting the wind every frame. It's kind of like a cool like Eye of Sauron. And I don't know why my water surface is rising up like that. That's an unexpected result that I can't quite explain. Cyst of Sauron. Oh, I know why the water. That makes sense because I burned away all the water. And then, whoa, that got out of control. And then it just created like a giant tidal wave. God. So that needs to be toned down. It's like, you know, when you hit a water drop, hits the water, and then it pushes down, and then it comes back up again. So I'm going to really try increasing how much wind is supposed to be affecting stuff. I messed something up. Okay. I told you not to pick at it. So I'll be on for just a couple more minutes here while I kind of look at the results of this, and then whoa, what the hell? Wow, that looks amazing. Oh God, I did a screenshot of that. Fuck. I want to see that again. Get ready for it. That's like Tool. That's like a Tool album cover. Screenshot captured. Oh my God. So something with enabling this wind is doing crazy stuff with the water somehow. I don't exactly know what. It's like a portal to hell, man. One more time. Oh my God. I'm trying to capture a screenshot, like just the coolest looking moment. So one more time. My God, this is madness! Madness! Seems to look a lot cooler in motion than it does in a still. But let's say I turn this off. Let's just say that for now. So maybe I was just putting too much like mass cramming together into a couple of cells. When I scale up those factors, that should GIF it. You're right. There's should I do video? Yeah. So I have two ways of doing Giphy. I got this like GIF tool that I use that can capture directly on my desktop, but it's a little more involved. But way that I think gets you a little better result is just to record a video and then upload it to Giphy. So I'm going to do that. I have a lot of video recording things. I have Streamlabs, OBS, I have thing called Fraps. I also have this one called Bandicam, and what I like about Bandicam, among other things, is that I can say just capture this specific region on the screen, like so. And I like to make it kind of, let me make the actual Unity window kind of square. This square is a good aspect ratio for GIFs. Turns out we're so used to looking at screens that are wide, like you have to go further than you think to make something actually square. It's like our perception, or at least mine, is kind of distorted. So that's a square. And what I'm going to do is zoom out just a little bit once the game starts before I start recording. Whoa, it seems a little bit different zoomed out like that. My god, that looks so fucking cool! Oh my god. Oh my god, it's so good. I think that green must just be like that water, interaction of the water with the rocks, like how the water absorbs light, like those streaks of green. Oh my god. Well, I think that's a good way to end the stream. So I'll be back on tomorrow, and then actually in the middle of next week I'm going to take a little hiatus because I'm doing some traveling, so my streaming schedule won't be so consistent from like the 21st, I think 20th to 21st until early September, and then I'll be back on 5 days a week. So see you guys tomorrow. Bye.